Hi Danielle, welcome back to the course. I'm glad that you had a good holiday. Um, I've got your midterm exam here that you wrote this morning, and I want to go over with you some of the corrections. Starting with the first question, when I ask you to do the derivative using first principles, then when you're substituting your x plus h value into f of x, then what you're really doing is just replacing the x with x plus h. And so you have to substitute in here the x plus h instead of x as it was in the original equation. When you expand that, when you multiply the 2 into the bracket, you get 2x plus 2h plus 4. So down on this line, you should have had 2x plus 2h plus 4 minus 2x, and then it should have been minus 4 because you're minusing the whole bracket, minus 2x plus 4. When you take that bracket away, it becomes minus 2x minus 4. So according to what you've got here, 4 plus 4 should add up to 8, and you ended up just with 4 there, so you've made another mistake in your calculations there also. Remember too that you know how to take derivatives using the shortcut now. So going back to a linear function like y equals 2x plus 4, you should have a constant for your derivative, which is y equals 2, just the coefficient of the x variable. And so it's a good way for you to go back and check to see if your answer is right. The other part of this is that you can't just get 4 by making h equal to 0, because you would be dividing by 0 on the denominator, which is not allowed. That gives you an undefined value. And so your final answer of x equals 4 is incorrect also, according to what you've got on that line there. For part B, you've done the same mistake that you did in part A. F of x plus h should look like this: 3 over x plus h all squared, which is 3 over x squared plus 2xh plus h squared. And then you would be subtracting your 3 over x squared, not x cubed there. And so again, if you try taking the derivative using your derivative rules just as a check, then we can see that y prime should be negative 3 over x cubed when we're done. And I don't think that you ended up there. No, you ended up at 0. So first principles is really, really important. Daniel, you're going to start your university first year course, calculus course. Trying to understand the concept of a limit and doing a lot of more complex calculations than this, a lot more complex functions. And so it's really important that you go back and review that. And if you need some help, let me know and I can help you out with that a little bit more. Okay? So let's have a look at Unit 2. For Unit 2, the first derivative that you took here, the first derivative is correct. Now let's just have a look at question 2 for a minute. Here's question 2, and for question 2 you need to use the product rule. You also need to use chain rule because this bracket here, this binomial, has its own derivative. X cubed has a derivative of 3x squared. So when you're taking your derivative, you're going to do u prime v plus v prime u. You've done this in the opposite order, and that's a bad habit to get into, especially when it comes to quotient rule. So follow this order, and you should have 3 times this bracket, which you've got over here, and that's correct. In the second half of your derivative, you should have function v, function v prime, which is 3 times x squared plus 9 squared times 3x squared for the chain rule, and then multiply by function u as you have here. So that 3x squared from the chain rule is missing, and then what you need to do is common factor and clean this up a little bit so that we would have a common factor of 3x cubed plus 9 squared and then for each of the terms you're going to write what's left in the square bracket. Okay, part C is correct. You've done the quotient rule in the correct order and calculated it correctly, so well done there. You may also want to go one more step and just factor out a factor of 3, but you don't have to in the numerator. It might just make it easier later on if you're trying to simplify that function or take the second derivative. Okay, again with C, you've started it off correctly. You've changed to the exponent 1/2. That's great. You've done the power rule correctly with the 1/2 in front times the bracket and then subtracted 1 from the exponent. The thing that's missing here is the chain rule portion of that, which is the 2x plus 3. That's the derivative of your binomial bracket, so that needs to be multiplied in, and then you would write your final answer as 2x plus 3 over 2 times the square root of x squared plus 3x. All right, question 2, you've done that perfectly. That's great. You took your first derivative and got a slope of 6, and then you used your point to find the other points on the line for the y-intercept. That's great. Now, let's have a look at number 3 together. Number 3, if you're being asked to find your maximum or minimum value and you're being given an interval, then they want you to find the local max and the local min in that interval. So you're going to begin by taking your derivative, and I don't see evidence of you taking your derivative here. You're going to set that equal to 0 to get the max or min point. And then you're going to test it to find out what kind of a point you have, okay? So x does equal 1 as your max or minimum value. You've determined that it's a max because the leading coefficient of our quadratic is negative, which means it's an upside down parabola, so that point will be a max. But you need to do it using the first derivative, and you need to check for max and min using the second derivative, okay? The other part of this question that's missing is that when we are finding the local max and min in an interval, we also have to check the 2 endpoints of our interval and see what y value we get. And so here we're going to get y equals 5, and here we're going to get 2. So if either of these points is lower or higher than the y value that you got for your critical point, then you may have another max or min in that interval. In this case, the local min, the absolutely lowest point in this interval is the point 3, 2. And so you have to list that as the lowest point or the local minimum in that interval. All right, Daniel, for question 2, your domain is not x, is all real numbers here. If x is equal to 1, then we get in trouble with this equation because we would have a denominator of 0 and an undefined value. So there's a hole in the graph, a discontinuity at the value x equals 1. So you have to write this in interval notation, that the domain is negative infinity to 1 along with 1 to positive infinity. That's the domain. The asymptotes are correct. Now you need to test them. For the vertical asymptote, you need to find out whether it's positive or negative as you're approaching from the left and the right, so that you know if the arrows are going up or down as you're getting close to the asymptote. For the horizontal asymptote, you have to test to see whether it's above or below, and if you go back and look at the content, you'll see examples of those tests. You've got your x and y intercept, but what you haven't done is find your derivative and second derivative, and you haven't tested for max and min, and you haven't tested for concave up and concave down. So those are missing from this solution. Finally, for Unit 4, please go back and work through your trig derivatives again. The derivative of cos is negative sine, but you're going to start with negative sine of 2x squared, and then you're going to multiply that by the derivative of 2x squared, which is 4x. For part, oh, I see, you've done that down here. Okay, so you're close. Sorry, that's not correct. You've written 2x. It should be x squared there. 2x squared. For the next one, e to the sine x, you want e to the sine x to stay the same. You're going to multiply by the derivative of sine x in this case, which is cos of x, not sine of x. Let's have a look at the next one. Okay, that one is correct. Your question C is correct. You've done your derivative right there. For D, oh good, you did that one correct as well. Yeah, you're doing really good with the exponentials and the log functions. For E, I guess we're looking down here. Yeah, you don't have to go through all the work for that. It's kind of a set formula for the log functions and the exponential functions. If you have the base 10 to the exponent x, and the general form of the derivative for exponential function like that is a to the x times ln a. And so everyone will follow that same pattern, and you can just jump right to the final. Okay, so please go back and go over these corrections. They're super, super important. You're going to really struggle in first year university if you don't understand them all. It's really not worth rushing through the material. It's better to take your time and make sure you've got a really good understanding. And please let me know if you need help with that.